Hello everyone, welcome to today's data analytica video. And in this video, we will actually see a data engineering project, a small one, that can be done using Databricks Free Edition and Airflow. Also, we will need Docker desktop to be installed. So let's start. In this video, we will actually see a data transformation, which is usually done from raw to bronze and then silver and then to gold pipeline. And also we will see an example for the changing dimensions, like for example, slowly changing dimensions SCD Type 1 and SCD Type 2. So, and also we will actually have this whole a job created for running the notebook, and then we will run that job in Airflow. So that's the plan. So let's begin with by adding all the required CSVs or the data files in the catalog. And here I am on catalog, and if you remember in catalog, in order to add new files or new data, so we have already this data, and we have volume created CSV files, and what we're going to do, we will actually create another volume, and we will name it as let's say data files. So I'm just naming it differently. So that's it, and it's going to be a managed volume, and I'm going to create it. And after that I will just, okay, maybe I can rename it to data engineering, because that's what we're going to do here. So, and I'll just drag and drop the required files. So I have two data files here, two data CSVs, one for orders details, and this CSV we will be using to create the pipeline from, like I mentioned, the usual pipeline of transformation from bronze to silver to gold pipeline. And also we'll have a customers data, so that I can show you example for the how to handle slowly changing dimensions using PySpark. So yeah, so that's where so we have, when you refresh the page, you should be able to see that we already have uploaded those two required documents. And now the next thing that we're going to do is we'll go to workspace and create a new notebook. And we will name it as PySpark Data Engineering. Okay, so let's begin, and let's start with importing all the required modules. So from PySpark .SQL import functions, let's say functions is F, and then from PySpark.SQL.window, so we will be using a window function as well, so we'll import that as a window. So maybe instead of F, it's better if we just import all of them. And then we can create Spark session. So it's already suggesting Spark session.builder.app name data engineering and get or create. Okay, so let's begin by running this. Okay, So it ran without any errors. So the next thing that we're going to do is maybe we'll just add setup. Load row CSVs. Okay, and here we are going to type orders row path is going to be, so it's going to be the location where we stored that orders file, and we have stored it in volumes workspace, then data engineering, and then PySpark pipeline orders.csv. Okay, and likewise we can actually get the customer's data row path as well. So I'll just copy this. Okay, so it's already suggesting, so okay, we don't need this for now, and I will change this to customers PySpark pipeline customers SCD. Okay, and after that we will actually create a data frame from this location after taking the data from this location. So that's going to be df orders row is going to be spark.read.option, and we'll keep header true, and then option info schema true, and we will get the CSV from this orders row path. Okay, so it's already suggesting for customers, and we're gonna I just clicked on tab to make it active because this is what we need. We will have spark.read.option, header true or info schema true, and CSV path is going to be customers row path. Okay, now let's use display to see how the data looks like. So we'll display 5 rows. Okay, df customers, okay, and it's orders. Okay, and after that we'll run this. Let's wait until it returns some data. Okay, so it's running, and here we can see that the first table shows the order table, order ID, customer ID, product ID, order date, quantity, price, region, and shipped. So just the basic info for each order, and then we have another customer table with customer ID, first name, last name, gender, email, address, region, effective date, end date, and is current version, etc. So all this data we have. And next thing that we're going to do is bronze. So we'll have like a bronze level. How to create bronze level is something that I'm going to show you. Bronze orders is going to be default. So default is actually a location in a catalog where we are going to save all the tables that are going to be created. So we use this default location before as well, like in my previous videos, and I'm going to use the same workspace, the catalog, to actually store tables created. So here I'm going to create a bronze table for orders and customers. So that's why I'm actually giving its name bronze orders. So this is going to be the location where it's going to be stored. And then we'll have the same for bronze customers is going to be, okay, default dot bronze customers. Okay. And how we are going to use this bronze, or how we are going to create this bronze, is actually we will have so we'll use the raw data. And honestly, the thing is that in the, like, when it's actually at the bronze level, you won't be able to see so much of difference when it's compared to the raw data. So that's how it's usually done, because we don't do the whole kind of transformation at the bronze level itself, because then it's difficult to actually see what was your raw data. Or so it's actually the processes of, there is not much difference when you compare your raw data and bronze data. So that's what we are going to keep here as well. But we are going to add a new column called ingest the timestamp. So when it was ingested, we'll add only this column with the raw data, and then we will store it in the location that has been provided. And then after that, we will write dot format. We will actually keep it delta, and then mode is going to be override, and dot option merge schema going to be true. Dot save as table bronze orders. Okay, and the next thing that I'm going to do is customers row. So likewise, we'll do it for the customers table as well. So we'll have in ingest here. So it's already suggesting what all the options, and I just clicked on tab because we just need that. So yeah, great. And once it's written, we will actually write that bronze tables are written. Okay. So we'll run this one. Okay. So we don't need this F. Okay, so I will just run this again. To be specific, I can actually keep dot functions, and then I'll import all. And after that, I will run this again. Okay, so here you can see that now it ran so without any error. And here actually you'll be able to see that we have added a current timestamp to this row data, and then we stored them as bronze data. So that's the bronze level. And next thing that we're going to do is to have the next level, which is bronze to silver. Okay, so when it comes to bronze to silver, we actually there can be like multiple things that can be done when it comes to transformation or the data transformation part. And first, let's try to actually see a window function. So we will see like how we can deduplicating. So something that we can achieve using, so let's say like when there are multiple entries by mistake, or let's say like and we need only unique order ID in orders table, then we'll have to do the deduplication. And for doing deduplication, using a window function can be very helpful. So I'm going to show you an example window function. So that's what we're going to do, window function deduplication. So this is a process, let's say like from bronze to silver. This can be a part of the process in transforming from bronze to silver. And how we will do that, we'll actually get the table bronze orders, and after that we will define the window. So window is going to be window dot partition by, and we'll partition it by order ID, and then we will order it by ingest TS. Okay, so in our case, actually, because we have this ingest timestamp as the same or the current timestamp for all the rows, but in our what we did in our earlier step, so I would say that we won't have much difference when it comes to this ordering or the descending order when we order it by ingest TS. But let's think about a real case where you have like this ingest timestamp, or let's say updated at, so there can be multiple different columns where you can have like this timestamp added. So it can refer when this order ID was created, and based on that you can actually deduplicate. So this is something very similar here what I'm doing, but I'm trying to say that because in our case, when we have like ingest TS the same, then it won't make much difference to have it ordered by descending or ascending. But still, we would like to, I just want to show you this windows function, which is very helpful. So with column, and we will have a RN or the ranking column, and then we will take row number dot over, so over this window, and what we're going to do is we will filter when this column RN is going to be 1, and we can actually then after that we'll drop this RN. So this is what we're going to do, and df duplicate comma limit 5, okay. Okay, let's see row number over W. Okay, yes, I forgot one bracket, so parenthesis. Okay, so the position of parenthesis was wrong. Okay, super. So now we should have like all the duplication. We shouldn't have any duplicated order ID here. So that's what we have done it here. So using this ingest TS, so in a real case, it can be like updated at or the timestamp, any timestamp field when the order ID was created. But because we didn't have any such ID before, so we actually created this timestamp where it's actually same for all as of now, but still we tried to order it by descending, and then we actually took the latest order ID and we dropped everything else because we ranked the latest one as 1 and we took only the 1, and then later we dropped the ranking column and also the others, so deduplicated. So this is one way of doing it. So, and because in our case when we have the ingest TS same for all, so we can do it in the second way, which is I'm going to show you. So in this method, we'll have like lots of other transformations included, not only window function thing. So how I'm going to do it? So silver orders is going to be, so we will store our silver table, the silver order table here, silver orders, okay. And so df orders bronze is going to be spark.table bronze orders. So this is from where we get the bronze data for the df orders bronze table. And df orders silver is going to be df orders bronze, okay, dot with column. So we will actually, what we're going to do, it will reformat this order date, and we will use toDate function, and then we will format it in YYYMMDD format, YYYMMDD, okay. Next thing that we're going to do is we will actually use, we'll change, there is this quantity. So yes, we have a quantity column, but we'll make sure that this quantity column is cast as int, okay. And so I just, it was showing suggestions, so I just clicked on tab and it showed like for the price column to cast it as a double, okay. For price column cast as double, that's what we did. And then we will have a new column added, which is going to be sales amount, and then call quantity multiplied by call of price, okay. And after that we will filter when the column order date is not null. So that means there is actually a legit order date for each order, okay, dot is not null. And so this is actually the another method where you can deduplicate. Instead of using a window and rank function, when you would like to take only the first occurrence of each order ID, then you can easily use this drop duplicates, which I think I already covered in my previous videos. So drop duplicates, and then you can specify which column you need to check for. So here I'm going to specify order ID so that it will actually take the first occurrence and then drop every other if there are actually duplicates, okay. So here we are, and so these are actually the transformations or changes we will do when it may change from bronze to silver. And after that, like we did for bronze, we will store this orders silver, okay. So it's already giving us suggestion because this is what we did for bronze table. So just click on tab, and here you can see that we will actually store it using the mode overwrite and the merge schema option, then save as table silver orders. So this is what we did for the bronze orders. So no major changes, okay. And post that you can print that silver table is written, okay. Okay, so the table has been written, and after doing these kind of transformations, here we have our table stored. So the next thing that we're going to do is, of course, from silver to gold. Silver to gold. So how we are going to do that, we can actually see, let's say we will first specify gold, and here, because we already added sales amount, it's going to be, let's say, saved as not gold orders, but instead of like, it's better if we actually do it in terms of sales, because now when we have sales amount for each order, it can be a sales data as well. So I'm going to call it as gold sales, and here it is going to be stored as gold daily sales. And we will take the silver data using silver orders. Okay, and df daily sales is going to be, let's say, df silver dot group by. So what we're going to do is, there can be multiple orders made on a order date for a region, for a product ID, etc. So we're going to use an aggregation here, and we will group by order date, region, and product ID, and then we will actually take what is the sales amount, or what is the total sales amount that has happened on that specific day for that group. So that's what we're going to do here. And okay, so we'll take sales amount and also the quantity. So let's say how we can do that. Group by order date. Okay, and then another when I mentioned region, then product ID. Okay, dot aggregate. So aggregate is going to be sum of sales amount, and we will call it as alias sales amount. Okay, and we will also have the quantity data for the units, alias units. Okay, and after that, df daily sales dot, so we'll write this data into, okay, so gold sales. So that's what we're going to do, and we can actually have a display to see how the data looks like. Okay. Let's see where is actually the problem. Okay, df, it's not dot, it's actually underscore silver. Yeah. Super. So if you see now, we have like order date, then region, and then product ID, and sales amount, and units. So we have now that like sales data from that orders data we had before. So if you look at like the transformation from bronze or the raw data to then to bronze, and then bronze to silver, and then silver to gold. So here you'll be able to understand what kind of changes you have. So let's say like we have we had like really raw data before with there can be multiple order IDs, there can be actually like different quantities, like it was not aggregated and everything else. So first what we did, like we actually stored it as a bronze using like just adding one more column to have a timestamp added, and post that we actually did some deduplication, and also we did some casting. We tried to reformat the date, and then we actually had like a sales amount column created because it was not there before. We used the quantity and price columns to create the sales amount. So that was on silver. and gold is kind of a pipeline level that can be used for analysis, because that is actually the sales data that salespeople might be looking for. So it's on a it's on a higher level than silver, but it's actually the data that can be used for a kind of different analysis. And when you would like to see the data in deeper, when you would like to analyze what maybe like you would like to see the order by details, like etc., then you go to the next level down, which is actually silver. Or when you would like to see the raw data, then you go to the bronze or the raw. So that's how this pipeline works. And I hope like with this very simple example, you actually understood like what's happening here and what how this bronze, silver, gold pipeline works. So that's what I wanted to show you. And the next thing that we're going to see is SCD, or slowly changing dimensions, which is actually very important when you need to handle different types of dimensions or etc. in real life cases. So here we will have first, I'll show you like how to handle SCD type 1. Okay, so here from the okay, so bronze customers, so we'll have like a, so we already have bronze customers created, so we will use that default bronze customers. And then we're gonna use this dim customers table, which is actually, which will be default SCD1 customers. Okay, the first thing that we are going to use is we will first initialize dim table. So how we are going to do is spark.read.table bronze customers, and then we will write it as delta dot mode is going to be override, and then we will dot save as table dim customers table. Okay, so the next thing that we're going to use is we will have, let's say, updates df is going to be bronze data. So we'll read spark.read table bronze customers. Okay. Read updates. So we have our timestamp data. Okay, and after that what we are going to do is we will keep, so on this bronze data that we have in our updates df, we will have a deduplication, so that we will take only the latest entry. So keep the first occurrence. So deduplicate by customer ID. So updates deduplication is equal to updates df dot. So this is this drop duplicates we have already seen in case of order ID. I'm just trying to do it for customer ID here. Okay, and the next thing that we are going to do is we will merge this data with the dim table. Okay, and how we are going to do it, we will actually keep merge into dim table, Okay, dim is going to be, okay, so in order to read, to have it accessed, so we'll have to use delta table. So I'll just import that from delta dot tables, import delta table. Okay, and we will use delta table dot for name. So we'll check for that specific table name, dim customers table. Okay, and after that we will use this merge function. So dim dot, we will call it as a D. Okay, this alias, and then we'll use merge updates deduplication. So we'll call that as U on D dot customer ID is equal to U dot customer ID dot when matched update all. And when not matched, insert all, then execute. Okay, so let me explain what this each mean. Okay, so if you're not familiar with this slowly changing dimensions type 1 or type 2, so in type 1, what happens is actually that we won't keep any history. So we will keep only the new or the latest data. Latest values without preserving history. For example, if a person has changed her department, so let's say there is an employee 1 who was working with department A before and now changed to department B. So when you follow this SCD type 1, all the records where there is employee 1, it will be changed to department B. And there won't be any record that he worked in department A, which is not an ideal case in some cases, but for some cases, yes, it can be ideal. So that's what actually followed here. So in this case, what happens? Department B will overwrite all records. So that's what we are doing here. So using this deduplication and bronze customers, we are dropping all the duplicates and we keep only the first occurrence which has the latest values or the latest dimension values for that customer ID. And using this merge, we are actually update whenever this occurs, and if there is no match, then insert. So it's a kind of upsert that we are doing here. So after this process, it should be that print SCD type 1 merge completed. And we can display, so let's say spark.table, we will take from dim customers table, and then we will limit to 5. Okay. Okay, so here this ingest is, it's actually like also will be, yeah, because it was actually same, but in let's say like in real case when there can be multiple kind of like a date stamp, only the latest timestamp will be there for each customer ID, and there won't be. Okay, So we will overwrite those values, those historical values, and keep only the latest one. So that's what SCD type 1, and that's what we have done here. When it comes to SCD type 2, it is, like I mentioned before, it is actually different. So how it's different is type 2. Okay, so it's that we will actually keep history. So history values, or the historical values with an effective date, end date, and so is current and version. So this is what we are going to keep, and how we'll do that I'll show you. So let's take the example that I mentioned before, that is actually employee. Let's say there is an employee 1, and he worked in department A for some time, and now he is working in department B. So in case of type 1, all the records will be overwritten with department B, and we won't have any tracking record that person worked in department A before. But with type 2, what happens is we will have two entries. So it will show like department A, but it will have an effective date and end date. So it will actually say that from this, let's say date DT1 to date DT2, this person actually worked in department A. And for this current, it will actually say, okay, I'll put a comma for different columns. So it will give a false value for is current. It's asking whether this is actually the current value, and it will give a false, and also we'll keep the version as 1. And then we will have like another row with department B, and it will actually have date DT2, because that is actually the date DT, let's say DT2 plus 1, because till DT2 he worked in department A, and then from the next day it started working in department B. And we will have the effective date as end date. Sorry, I think I forgot to put, yeah. End date is going to be null because that person is still working in department B. And then we will have true for the version that is current. It's actually the current value and then the next version. So this is how we will deal with these kind of changes in type 2 of slowly changing dimension. So these are actually the very most common handling ways, or ways which we handle slowly changing dimensions. But there are actually other types as well, but I think it's not so common. So that's why we are going to discuss type 1 and type 2 here. So how we will handle that in case of customer, let's see. So we'll keep adding customers SCD2 equal to SCD2 customers, okay, and then we will initialize dimension. So initial dim is going to be spark.table bronze customers, okay. Bronze customers, and then we will keep all these columns we already have, but we will still keep the effective date as we will give a value to date. Okay, we will change this to 2023-0101. Dot with column, we'll keep end date, and we'll give the value null, lit of none, none, and we'll cast its date. Column is current, so we'll keep true. With column, and the version is going to be lit of 1. Okay, and the next thing that we will do is, so yeah, yes, we will actually have it written to dim customers SCD2. Okay, and then we will have a dim table, and we will dim delta table dot for name, so we'll call that dim customers SCD2. Okay, okay, and the next thing that we are going to do is, let's say there is some address change that has happened, and we'll actually need to track it. So let's say like we will have an updation to the row. So spark.table bronze customers. So we'll take only 50 of them. And this is kind of a simulation that we're doing. Okay, sorry. With column, address. Okay, concat, let's say address, so we already have an address column, and also we will keep a literal value of new, so just to be with column, and effective date, we will keep an effective date, to date of, let's say in 2024 0701 dot with column is current. Column, and we will have an version update, so we'll keep version as call version cost of int, so we'll give it actually the next version value. Okay, so this is a kind of let's say like I'll keep simulated updates to show this kind of a type 2 handling. So that's what we're going to do. So when a change in tracked attributes occur, so when we do the merging, so I can show you how we're going to do the merging. So we will do the dim table dot alias of d, like how we did it before, and then we will do the merging, and we will do it with updates row alias u, and then there is a condition that we are going to check. So we will check dim.customer id is equal to u.customer id, and d dot is current equal to true, and d dot address when the address has changed, u dot address, okay, or let's say a region has changed. Okay, then what we are going to do is when matched update, so what we'll do is we will set this, then is current is going to be false. And we will actually keep the end date as the effective date of the changed one, so that it actually shows that till that date that version actually was active. Okay, and when not matched, insert all. Okay, and display spark.table dim customers SCD2. Let's say 20 rows. So let's see how this actually works. Okay, so if we look at the data, let me order it by, let's say, customer ID. Okay, so let's try to analyze the results, and so let's go to this effective date and also the is current column, and let's try to filter when it's false. So that means okay, and here if you look at this, there is this value of customer ID for which there should be two entries. So let's see if we have two entries, one with false version and another one with true. Okay, so here we have only one, which means there is something wrong with our approach. So okay, let's see what it is. So we need to check if that means actually the new row, it's not getting inserted properly. So let's try to delete this part and let's try to dim table dot alias d dot merge. Okay, so updates row dot alias of u, and we will put the condition that is d dot customer id is equal to u dot customer id, and d dot version is equal to u dot version. Okay. So here, so this actually does when not matched, so insert all, and then we will execute. Now let's try to run it again. Okay, so there is, yeah, we missed a parenthesis. Okay, super. So if you look at this now, here you have like, this is actually an entry for this customer ID, and which this is actually address, because we simulated it that way. We actually changed the address to have a new, as we did concatenate. So this is the new address for that customer. So we will actually keep the historical value, which is effective from this day to this date, and that is actually not the current version, and it was version 1. And then we will keep the latest version as the second version, and we will keep is current as true, and then end date keep it as null. So this is the right value that we need to get when we do the SCD2. That means we are keeping both historical and the latest data. Whereas in case of type 1, it was actually only to keep the latest value by replacing all the historical values with it. So that's it about SCD2, and hope it was actually, this session was useful. And in the next session we will actually do the, so I think we already have enough long video for this one. So for the next part 2 will have a job ID created. Then we will set up Airflow. Also we'll set up DAG, which will actually run this Databricks job ID. So here we will do everything with this free edition, so that I'm not creating any cluster or anything. So here this is actually something that you can try with the free edition. You don't have to pay additional for it. So that's it, and see you in the next video of part 2. And let me know your comments if you find this useful or if you find something is missing. So please let me know. Thank you.